And we're live back once again. Excellent. Oh my. What a day. What a day. Supposedly, we're supposed to be getting snow tonight into tomorrow. Man, I wonder if they'll have you guys stay home tomorrow. Ha ha, ha ha, ha ha, ha. Anyway, please leave a comment in the chat for me, just so I, number one, have it for my records, and number two, I can see who's here, of course. That would be fantastic if you would. There he is. I'll give you a brief outline as to how class is going to be running today, and then I'll go into some more finer details as to what I need you to know, because I'm just giving people an opportunity to get into the chat. Somehow my 9 people who were with me just a moment ago dropped to 4. That was weird. Makes me sad. As I see y'all in there. I'm gonna do the crab wave. This is my crab wave. That's how I wave to people now. I decided that is going to be the way that the future goes. Whatever, it happens. In terms of today, we are going to get practice on solving radical equations. I'm going to have to take it a step farther than what we've done. I do have some resources that I'm going to make available to you via Google Classroom when the time is appropriate, so that you can see exactly what problems I want you to be working on. But like I said, there's a bit of information that I want to go over with you first in regards to solving these things. I have to give you a few definitions along the way as well. As a reminder to all that are here, you do have a quizzes due today. I believe I made, and I'm double checking that right now. Yep, I made the due date. Due at 2 o'clock. Not that many have done it. But yeah, that thing is due at 2 o'clock today, and you do have 3 attempts at it. So if you have not done that online quizzes, you need to make sure that you get that thing done. Yeah. In the meantime, if you do not already have them out, I'm going to need those notebooks out and open. Now, in regards to, again, the chat, leave the comment there if you haven't already. I am going to have that chat open over here where I'm sitting, so that we can all be on the same page if you have those particular questions. Not only do I need those notebooks out and open, but I would also ask in a moment that you check the Google Classroom. I just have to attach the PDF that I need. There it is. Post. And posted. There we go. So if you have that notebook out and open, that's fantastic, number one. Number two, I also need you to check the Google Classroom stream so that you can see the PDF that I just posted, because that PDF is going to inform a lot of the problems that we end up doing today. That'd be fantastic. I see you all in the chat right there. Let me flip my screen over so that we can begin with what we need to begin with. You can see right there. Hold on, there's my phone with the chat so I can see y'all. That'd be great. Again, if you have any questions, that'd be fantastic. So, first and foremost, today, my word, February 10th. Hope I got that right. Yes. And this is going to be solving radicals practice. Solving radicals practice. Now, the PDF that I sent you looks like this. The PDF that I sent you looks like this. It has a kind of a different, this is from a different textbook, but I do like these particular problems better than the ones that your textbook actually offers. So yeah, you've got to make sure that you have that PDF. Um, I'm going to refer to those problem numbers. So if you wanted to copy down exactly what it should be, if you can't see what's on the board, that would be fantastic. Let's see here. Come on, problem, be my friend. Let's start off pretty much where we left off with a problem like this. Off of that worksheet, this is example number 3. Example number 3. Example number 3 is 2x with a 3/4 exponent equals 8. That is the problem that we have. Now, a lot of the issues that I've seen people face on problems like this is they try to take certain steps before they're allowed to. What I mean by that is this problem has a 2 in it that you really want to divide by. You feel like, I really want to divide by 2. 8 divided by 2 is 4. I can move on from there. However, that is not the correct first step. There are parentheses surrounding that 2x. Last class, I introduced the concept of SADMAP. SADMAP is PEMDAS backwards, and it basically tells you the order in which you should be peeling off these layers to solve for the variable. What I mean by that is this. If you go SADMAP, addition, subtraction, nothing. I can't do it. Okay, next. Multiplication, division. Well, there's a multiplication right there. Yes. But when do you deal with parentheses? In SADMAP, the parentheses come last. So you have to deal with the exponent first. If I'm looking at this problem, let me zoom in a little bit on this problem. There we go. I got to get rid of that exponent. Now, you could, if you wanted to, convert radical form, blah, blah, blah. But the easiest way to go about this, the absolute easiest way to do this problem, is by raising both sides to the reciprocal power. Raise both sides to the reciprocal power. Now, again, I bring you back to something that I showed you last class, where we would raise to the reciprocal power of a power. We would end up canceling out this exponent because multiply the exponents together, boom, they cancel each other out. Fantastic. But I ask you a rhetorical question. Kind of rhetorical, but I really want you to think about it. Do I need to put in a plus or minus? Do I need to put in a plus or minus? Now, some people would say no, and some people would say yes, and then I would stand here silently, and then they would change their answer, and they would not know what to do because they were guessing in the first place. But here's what you need to know. You put in this exponent. You introduced the exponent of 4 over 3. That exponent was not on the original problem. You introduced a root to the problem. But what type of root did you introduce? 4 over 3 power over root. You introduced a third root to the problem. More specifically, an odd root. I gave you a starred statement last time in class, and that starred statement said that if you introduce, oh wait, it said an even root. If you introduce an even root, you need to put in a plus or minus. But you did not introduce an even root. You introduced an odd root. You do not need the plus or minus. It is your job to recognize when you need to include or not include that plus or minus. You absolutely have to recognize that. Only if you introduce an even root. So in this case, we're fine. We don't need a plus or minus because this is the third root. Okay. On the left side of the problem, those exponents cancel each other out, leaving me with a 2x. On the right side, oh, snap. On the right side, I have to evaluate that thing. Well, Mr. Markey, can't we divide by 2 now? No. You can't divide by 2 right now. You have to evaluate that 8 to the 4/3 power first. Then you can divide by 2. Yes, dividing by 2 should be the last step we take. It should. But you need to figure out what this value is before you divide by 2. So, this is actually the third root of 8 to the 4th power. Again, I bring your attention to power over root. It is a 4th power. It is a third root. The third root of 8 is 2. And 2 to the 4th is 16. And then finally, after all of that, you can finally do the thing that you actually wanted to start the problem with. You can divide by 2. And you get your answer. Oh, happy day. Now, it is your responsibility to check your answer. I'm going to bring your attention to something on that worksheet in a moment. But it is your responsibility to check your answer. I can take that 8. I can plug it back into the equation. And as long as I follow the appropriate order of operations, it should work. Let's check it. 2 times 8 is 16. The 4th root of 16 is 2. 2 cubed is 8. It works. Yeah. Now, what I want to bring your attention to is that worksheet that I had posted into your Google Classroom. So check this out. Look at the worksheet that I posted into your Google Classroom. The directions up and down this page say to solve the equation, but then to check for what is that? Look at that word. Y'all see that word? Again, you have this PDF. I put it in your Google Classroom. You can take a look at the exact spelling of that word. But it says to check for something called extraneous solutions. What the heck are extraneous solutions? I will give you a definition of extraneous solutions soon, today. But let's wait a couple problems. Let's wait until something pops up. So let's try another one. Where's my little paper here? Let's try. Ooh, that's a good one. Number 18. Number 18. I'm going to jump around this thing a lot today. But this is number 18. I have to switch my marker soon. This one's dying on me. But let me write down number 18. 5 minus the square root of 2x plus 1 equals 3. Okay. Okay, we could do this. 5 minus that square root equals 3. I mean, clearly 5 minus 2 equals 3. But, 2 is not the answer. Let's see what happens. Now, there are several things preventing you from getting that x by itself. First, you have to recognize that this 2x plus 1 is in its own set of parentheses, and you cannot touch it until you get everything off of the problem around it. You can't touch that 2x plus 1 until you get off the 5, the minus, and the radical. That's the first thing I need you to recognize. Second, according to SADMAP, you are to deal with addition subtraction first. This is where many people make a huge mistake. This problem is where a lot of people stumble and crack their nose on the ground. A lot of people tell me, Mr. Markey, your first step is to add 5. And I say, no, it's not. And they're like, what are you talking about? And the conversation just goes back and forth like that for a while. Usually it's like a half an hour back and forth. And I say, no, it's not. And they say, yes, it is. But your first step is not to add 5. Because if you added 5 to both sides, this 5 would become a 10. And that doesn't help us. This is already a positive 5. The reason why they say add 5 is because they see that minus sign. But that minus sign is affecting the square root, not the 5. So my first step here would actually be to subtract 5 from both sides. That would be your proper first step. If I do that, that negative comes down for the ride, and I get this. We have to be very careful with the steps that we take. Incredibly careful. Part of the reason why people hate math is because they make tiny little mistakes. Like the tiniest of mistakes. Like, oh, I forgot a negative sign. But it ruins the whole problem. Some people say that's what they hate about math. That's what I say I love about math. The fact that math is so incredibly precise and that the tiniest of mistakes can ruin the whole thing, that's perfection to me. Like a puzzle piece that fits just so snugly exactly where it's supposed to go. Now, that's not just a negative in front of that square root. That is a negative 1 times that square root. That is a negative 1 times that square root. I need to get rid of that negative 1. So I'm going to divide both sides by negative 1. Again, the general idea is that you follow SADMAP. You take care of any outside addition subtraction first, then you take care of any outside multiplication division second. SADMAP. Then exponents, which that square root falls under the category of exponents. Because power over root, it's a 1/2 power. This becomes the square root of 2x plus 1 equals positive 2. I'm going to square both sides. Whatever you do to one side, you have to do to the other. You have to follow a logical progression. The square will get rid of that square root, leaving you with the 2x plus 1. You are finally inside the parentheses, and now you have a basic algebra problem. Like a basic algebra problem. That's so weird. All right. Subtract 1, divide by 2. You get a decimal. Yes, you get a decimal, but it's a nice looking decimal, 1.5, or the fraction 3 over 2. You have to check your answer. Now, you don't know what extraneous solutions are just yet, but you will eventually. But for now, you got to check your answer. Let's see. Plug in that 1.5. 2 times 1.5 is 3. 3 plus 1 is 4. Square root of 4 is 2. 5 minus 2 is 3. It works. Yay! High fives all around. Wonderful. I'm going to give you a few problems to work on. I'm going to give you 2 specific problems to try on your own right now. And I'm going to give you roughly 5 or so minutes to get them done. I'll write them down on my page, but I'm going to tell you what problem numbers they are so that you can just go straight to the PDF and copy those problems down as is. I would like you to get done from me, and I'm going to split my page here. There we go. I would like you to get done from me number... Oh, that's a good one. I would like you to get done number 9. And I would like you to get done number 17. I'm going to give you the next 5 or so minutes. I'm keeping an eye on the clock. And I would like those 2 particular problems done. You can put them into your notes, and then I'm going to confirm what they should have been, basically. Again, there's more than one way to do these problems, but typically for these problems, there is kind of a set pattern to them, so to speak. But again, you need to go to that worksheet, the worksheet that I posted into the Google Classroom this morning. Look at that PDF, and I want you to copy down numbers 9 and 17. The next 5 minutes, get them done, go. All right. It's been a sufficient amount of time. Let's take a look at number 9. Number 9 gives you the following problem. There's a negative, a set of parentheses, a 1/2 power plus 3 equals 0. Let's game plan. Now, when I say game plan this problem, I mean I want to try and visualize what it is that I have to do to this problem in order to get the variable by itself. First, I can't touch those parentheses until I peel off the other layers surrounding it. So save the parentheses for last. There is an exponent. There is a -1 being multiplied by those parentheses. Don't distribute it. You can't distribute that -1. And then there's a 3 being added at the side. Equals 0, but I'll deal with that. Okay. I'm going to subtract 3 first. Again, SADMAP. SADMEP. SADMEP. Deal with addition subtraction first. Outside layers. Subtract 3. Subtract 3 to start this process. It's similar to the problem that we just did with the negative sign in it, just in a different order and look in a different way. That's a -1 being multiplied by those parentheses. I'm going to divide. I've taken care of all outside addition subtraction. Now I got to divide. I'm going to divide everything by -1. It cancels out that -1 in front of the parentheses. I'm left with 3x plus 4 to the 1/2 power equals +3. Now this is where we have to logically see what power over root means to us. Power over root is a fractional exponent. Power over root is what we see when there is a radical on the problem. This fraction, 1/2, power over root. That is a square root. The best way to take care of a square root, as long as it is the outside layer, is to square both sides of the problem. And yeah, if you raised both sides of this problem to the second power, if you raised both sides of this problem to the second power, like so, it would cancel out that 1/2 exponent. You are not allowed to distribute that 1/2 exponent. That is something that we've covered in exponent properties. You can't distribute that 1/2 exponent because of the addition subtraction here, but you don't have to even worry about it because you're just trying to peel off those outside layers. The 1/2 and the 2, power of a power, multiply, cancel each other out, leaving you with 3x plus 4 equals 9. Now it's just a matter of like pre-algebra, algebra 1 stuff. At this point, right here at the bottom, subtract 4, divide by 3. You're going to get a fraction. And that's okay. Subtract 4, divide by 3. You get the answer 5/3. Yay. Now, I have to check my answer. I have to check my answer. If I take that 5/3 and I plug it in, 5/3 times 3 is 5. 5 plus 4 is 9. 9 to the 1/2 power is really saying square root, which is 3. 3 times a negative is -3. -3 plus 3 is 0. It works. Notice I don't have to write anything down to check my answer. I'm just kind of visually plugging it in, just seeing if it works. You typically don't write out checking your answer. You can if you want to. It can be helpful. But you have to plug it in. We're almost getting to the point where plugging it back in won't work. And I want to explain to you why that is. Let's look at number 17, though. Number 17, 2 times the cube root of 1 minus 3x plus 4 equals 6. Again, keep in mind that that 2 is being multiplied by the cube root. Just kind of hanging out, being multiplied together. You can't touch that 1 minus 3x yet. You can't touch it yet. You can't touch the 1 minus 3x until you peel off the other layers. So, game plan, SADMAP. I'm going to subtract 4 first. I'm going to divide by 2 next. I'm going to figure out how to get rid of that cube root. And then I'll be inside the parentheses. All right, let's do it. Subtract 4. If I subtract 4, 6 minus 4 is 2. I'm going to divide both sides by 2 because that 2 is being multiplied, leaving me with the cube root of 1 minus 3x equals 1. So far, so good. Now what am I going to do here? It's a cube root? Oh, right, cube roots. I just cube it. What is 1 cubed? Again, don't stumble. Don't stumble when I say 1 cubed. Cubed, cubed. On the left side, they cancel, and now you are finally inside of the parentheses. On the right side, hey, 1 cubed is just 1. It's just 1. 1 times 1 times 1. Sometimes people make it a 3. Don't do that. Don't be a jerk. Subtract the 1. Now, again, you have to subtract the 1. That 1 right here, the thing that I'm pointing to right now, that's positive. That's a positive 1. That negative is on the 3. Subtract 1 from both sides, leaving you with negative 3x equals 0. After all of that, divide by negative 3. Divide by negative 3. You get an answer of 0? Really? That's one of the reasons why I love it. You get an answer of 0. 0 is an answer. Don't think that getting 0 means, oh, it's nothing. No, 0 is something. Plug it in. See if it works. All right. We'll see if it works. No, for real, we're going to do that. Plug in the 0. 3 times 0 is 0. 1 minus 0 is 1. The cube root of 1 is 1. Times 2 is 2. Plus 4 is 6. It works. It works. Interesting. Now is the time I got to show you. Now is the time I have to show you. Ladies and gentlemen, I need you to copy down the image that I am about to draw up here. And I need to write a few notes about it. First of all, these functions are, for the most part, square roots. I mean, a lot of them are not, the cube roots, fourth roots, whatever. But a lot of them are square roots. And we know what square roots look like. I need you to copy down something here. First of all, let's just say that I had a square root function that looked like that. If you remember, square root functions tend to look like parabolas, but sideways. They look like parabolas, but sideways. All right. And then let's say that I had another line going through this, like this. That's acting as a horizontal line, mind you. Let's just pretend that that's a horizontal line. When we solve these equations, we are really finding a point of intersection. Right there. I drew a little arrow. When we solve these equations, we are really finding a point of intersection. We are finding out where the two lines or curves or whatever cross each other. That's what we're really actually finding out here. I want to make a big deal about this, a very big deal about this. Because there is a ghost in the machine. Now, a lot of you may not recognize what that means when I say ghost in the machine. Some of you might. But a ghost in the machine is a metaphor for leftover code. Leftover code that's just kind of floating around and doesn't really have an impact until it does. The ghost in the machine is like leftover code that someone probably didn't delete or something along those lines. There's something that is going to happen with the next problem that I give you. And it has to do with finding that point of intersection. Let's see what happens. The next problem that I want you to write down, and let me just confirm that this problem is indeed the one I want you to work on. Heck yeah. It's number 23. Now, I am hyping up this problem in a very big way because something is about to happen that is going to mess with your heads. Actually, several things are going to happen. The first thing that I want to point out is the fact that there's a variable on both sides of the problem. The first thing that you must try to do is get rid of that radical on the left side, which you can. You can because that square root on the left is the outside layer just for the left side. I would like to square the left side to get rid of it, and I will. Watch this. Look at that junk. Squaring that left side will leave me with a 2x minus 3. Good for me. Whatever you do to one side, you have to do to the other. If I'm going to square the left side, then I better square the right side. Notice how I just did that. Can you feel it? Can you feel it about to happen? Something's about to happen. If I want to square that right side correctly, I'm going to need to multiply x minus 3 times x minus 3. I cannot just distribute that exponent. I actually have to either FOIL it out or do a box. I'm going to do a box. You have to multiply this out correctly. It is vital that you multiply this next part out correctly. Otherwise, the entire problem is going to fall apart. As I mentioned earlier, even the tiniest of negative signs, if you're off by a negative sign, it's going to throw the whole problem into disarray. You can't let that happen. X times x is x squared. I get a negative 3x here, a negative 3x here, and a positive 9 there. Notice the left side of the problem is still just the 2x minus 3. I'm going to recap exactly what happened, and then you're going to see exactly where this problem is going. Oh my goodness. See, at the beginning of this problem, it starts off just like any other problem that we've done. There is a square root problem in which we can get rid of that square root by squaring both sides of the problem. Yay! The only issue is the fact that there was another variable on the other side right there. There's another variable right there. So when you squared both sides right here, when you squared both sides on the left side, that square root went away, leaving you with the 2x minus 3. Oh, happy day. On the right side, you're going to have to multiply this out correctly. X minus 3 times x minus 3, meaning you could FOIL that, or you could do a little box method here. By doing that box method, we get x squared minus 6x plus 9. And guess what? We're back. We are back in chapters 4 and 5. We are back at solving quadratics. I spent a good deal of time in September and October focusing in on solving quadratic equations. Spent a good deal of time on that. Something that you started in Algebra 1, something that we continued in Algebra 2. This is one of the reasons why. Because this radical equation is secretly, actually quadratic. Surprise. So, where does that leave us? I got to get one side equal to 0, which means I need to add 3. I need to subtract 2x. And I get this brand new quadratic at the bottom of the page. Now, with this brand new quadratic, you can do any number of things. You could do the quad formula. You could factor it. Factoring is probably easier in this case, since it's a 1x squared. 0 equals x minus 6, x minus 2. That's what we did earlier in the year. Negative 6 and negative 2 add up to negative 8. Negative 6 and negative 2 multiply to positive 12. Yay. We get two answers. We get an answer of positive 6, and we get an answer of positive 2. Do not circle them yet. Do not circle them yet. We need to check our answer. And by checking our answer, I mean this. We need to go back to the original problem, and we need to test to see if those numbers work. So I'm going to zoom in on my original problem. There's my original problem at the top of the screen. We got an answer of positive 6 and positive 2. I'll recap how I got that in a few minutes. Let's check the positive 6. If I plug in the 6 right here, 2 times 6 is 12. Minus 3 is 9. The square root of 9 is 3. So on the left side, you would have gotten 3. Let's plug that 6 in over here. 6 minus 3 is 3. It works. Now I can circle that positive 6. Actually, you know what? I'm not going to circle it just yet. I'll rewrite it and circle it. But now let's try the 2. Watch very carefully when I try the 2. 2 times 2 is 4. Minus 3 is 1. The square root of 1 is 1. So we get 1 on the left side. But when I plug that 2 in over here, 2 minus 3 is negative 1. It doesn't work. Did we make a mistake? No, we did not. We did not make any kind of mistake. This is the ghost in the machine that I was referring to. This is what we refer to as an extraneous solution. After we solved the quadratic, we got 2 answers. We got an answer of positive 6. And we got an answer of positive 2. However, I am going to label that as extraneous. What does that mean? It means that 2, although it is a solution, is what we call a false solution. Where it comes from, I can visibly show you in a moment. But it still counts technically as a solution. Some people would just throw it away. But you can count it as a solution. It's just what they call a false solution. Okay. Definition. Extraneous solution or solutions are false solutions. They still technically count under the realm of solutions. It's just that they are false. Meaning when you try to plug it back into the equation, it gives you a false statement. Where it comes from is literally what I'm about to show you. Imagine that you had a square root function that looked like that, and I would like you to draw that as well. Imagine that you had a square root function that looked like that, which you could. Absolutely, you could. Now imagine you had a line going through it right here, which you could, of course. The solution is the point of intersection. The solution is the point of intersection, as it was earlier. That's technically what you're finding. And if you notice, there's only one point of intersection. However, sometimes, now I say sometimes because this is not a guarantee to happen all the time. It's not. Sometimes a second false solution can be found from the other half of the curve. Let me repeat that statement. The solution is the point of intersection, and that's what I just pointed out right there, where those two lines cross each other. However, sometimes a second false solution can be found from the other half of the curve. Mr. Markey, what do you mean the other half of the curve? Well, remember, square root functions. What do they look like? Square root functions look like half of a parabola on its side. The other half of this parabola doesn't exist, but a second false solution could be found. Now, you must label it appropriately. You must label it appropriately. You must label it as extraneous. You have to. In the problem that we just did, where we got an answer of +6 and +2, you're not going to know which one is extraneous just by looking at them. You have to plug them in. In fact, check this out. I'm about to go to Desmos. I'm about to go to Desmos right here. Check this out. Desmos. Okay. Let's see if I can't get a square root thingy here. Square root 2x minus 3 and y equals x minus 3. Let's bring that over right there. Okay. And that's good. Okay. Now I'm going to point out something on the board here. The red curve is your square root function. The red curve is your square root function. That's the one that we just did. That is the square root of 2x minus 3. And the blue line is the linear function x minus 3, which clearly they only cross once. And where, pray tell, do they cross? Desmos will tell me. Clicked it right there. They cross each other. They actually have a point of intersection at x equals 6. And you can visibly see that. There is a second solution. We got x equals +2. Where did it come from? It came from right here. X equals positive 2. Except, as I've stated before, the other half of that parabola does not exist. Square root functions are simply put a half of a parabola on its side. If the other half of this curve existed, then this would not be a function. Thus, this limb is gone. It's been amputated. But even though it's been amputated, the ghost of an answer is still there. You ever hear of phantom pains? Phantom pains are when somebody has a limb amputated for whatever reason, accident, disease, I don't know. And then years on down the road, they still feel certain things. Like, for example, if my left arm were amputated and it was gone, and then like 10, 15 years down the line, it's like, oh man, my left hand, it's hurting. Oh wait, I don't have a left hand. It's in the brain. It's called a phantom pain. It's like a phantom solution, except we call it extraneous. Ladies and gentlemen, I will remind you that you have a quizzes due for me today. Not everyone has done it. It is due today at 2 o'clock. You have 3 attempts. We're going to continue with more of this on Friday, give you some more practice, and we'll see how we're going to wrap up this chapter, because this is the last unit in the chapter that we're covering. There's the bell. I will see you next time. I did it again. Anyway, everyone take your stuff. Take your stuff. Go, leave. Social distance in the hallways. Get up and leave. Go. Okay, no one's leaving. Get out. We'll see you next time.